relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is put equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Kokra and Walton in 1932 experimentally.
To start this video, I would like to propose an exercise of thought. Let's suppose that we are far in the future, and we, as a civilization, found much more efficient ways to transform energy, which got to the point that traveling at speeds really close to the speed of light is possible. Awesome! That means that we can go far beyond in deep space. We could maybe visit other galaxies, other planets, and who knows, maybe other universes. But you decided you did not want any of that. You just wanted to cross the sky, visit your own planet, and use this technology to understand the Earth. And that's what you did. You stole your dad's portable flying device and you flew up and high in a speed really close to the speed of light. But I forgot to mention, you brought a mirror with you, a regular mirror like any other. And that's when the exercise of thought I mentioned comes along. Think about it. What will you see at the mirror if you confront it to your face while you fly? What will people in the ground, like your probably furious dad, see in the mirror? Well, Einstein proposed this question to himself and took 10 years to answer. It was only in 1905 that he came up with the solution. Light is constant. And by constant I mean it's always the same for any point of view. You may have heard somewhere that Einstein said that everything is relative, but as most quotes people attribute to him, that is wrong and was probably never mentioned by him. But okay, as you may know, that is not it. This had many consequences that affected many people, including you. You're probably thinking, how the simple assumption led to so much? Well, if the speed of light does not change relative to any other thing moving, the speed of light is not achievable by any other matter we are aware, which implies that we, or any other kind of matter, higher speeds, probably do not behave the same as we are moving. So, if light is constant, all other aspects we are used are not, depending on our speeds of course. The idea that mass, time, distance, and everything else are constant seems to be a mere illusion of our minds and the limited experience of reality we have. Well, it was all a basic assumption in which Einstein arrived by logical reasoning. His ideas follow such a different path in reasoning that his first paper had no external references on the footnotes. But there is more we could imply on that. In Stephen Hawking's words,
if energy is used to accelerate anything, consequently the mass of the accelerated object increases relative to non-motion matter. More energy means more mass, and accelerating to infinity would mean infinite mass and infinite energy.
as human beings, we are definitely not used to anything that is infinite. But the idea appears to be inferred in the natural world. And by inferring, I mean we have an equation. Yes! Einstein joined his logical conclusions with what he previously saw in other electromagnetic equations, and voila! Boom! E equals mc squared. This junction of ideas matches and represents the whole concept of special relativity. If the speed of light, represented by c, is a constant, more mass, more energy, and vice versa, it all matches. But what you probably do not know is that this is not the full equation. Well, this non-simplified version of the equation plays with momentum, adding moving matter to the equation. To make it more clear, if the object is not moving, his momentum equals to 0, right? Which leads to the simplified version. In summary, as predicted by the previous electromagnetic equations, if the constant of light is a square, increasing both mass or energy leads to much more energy than any conventional bomb. Even one strand of your hair reserves energy that could destroy more than a TNT. It's all on that equation and how light behaves. And that leads to the consequential. Einstein's equation had more implications to the scientific community and to the world than anyone else had expected. If atoms conserve all the energy, would there be a way to release it? If yes, how and for what? For the government of the United States of America, the answer was, as you may know, a bomb. As you know, the result was catastrophic, and I hope we, as a human civilization, comprehended the lesson from it. On the bright side, relativity led to several expansions of the field of physics. New gravitational model, black holes, new mechanics, Big Bang, new cosmologies, and much more. It did not perfectly match with every physical theory, like the quantum theory, but it got us into a new track. The scientific community became more apt to major changes and getting out of the box. But everything started with questions. Questions. The point here is that questions lead us somewhere. And how can we take advantage of that? Well, Einstein looks to be the answer, right? From what we saw, Einstein took a different approach from the scientific community of his time. He stuck with the questions he had and was not satisfied with any regular question. He left his own bubble of knowledge and spent 10 years looking for an answer. On the words of Mort Orman, The truth about life may not be what we have been told. The truth about life may be very different than what most learned people believe. We don't always need proof, evidence, or the agreement of others to embrace a new truth if we have good reason to believe in its utility. It's all about leaving the box of convention to seek knowledge from different approaches. That is the base of information and our closest definition to evolution. Our existence can be much more than what we expect today, and that new reality can only be approached by minds that follow their own perspective of reality. Yes, we are influenced throughout the way, but reflecting upon those perspectives and how they can be overseen is what can truly change the world. Thank you.
We ask your help in this fateful moment as sign that we scientists do not stand alone.
I agree.